Hi friends, so we are dealing with the side effect of scheme language. Okay. Side effect means changing the value of a variable. Okay, and we don't have a big definition for side effect, but if there is a function, consider that there is a function, and if that function changes the value of a variable, if a function changes the value of a variable, we say that the function do have a side effect. If a function changes the value of a variable, then that means that the function do have a side effect. Actually, this side effect is a property of a procedural language. Okay, side effect is actually a property of a procedural language, but scheme also do have some statements which causes that which causes or which imparts the same features of this procedural language. Okay, so scheme do have something called assignment, begin, and iteration, so that it works similar to a procedural language. Okay, so these are the things that imparts side effect to scheme language. I hope this actually side effect is for procedural language, but these things, assignment, begin, and iteration, since it is present in scheme, it can also scheme also acts as if it is a procedural language. So scheme cannot be thought as a fully functional language. So we'll discuss about each and everything. The first one is the assignment. Okay. To explain the assignment, we will be using something called set. Okay, actually set is used to change the value of a variable. Set is used to change the value of a variable. Okay, the keyword set is used to change the value of a variable. Okay, here I have written something called the let. Okay, so let is for defining a variable value. Okay, defining a variable or giving a variable some value, we will be using let. Okay, so here we can see that let x2. That means initially the value of x is 2. Initially the value of x is 2. Okay, and here I have written that L space after a single quote AB. That means since there is a single quote here and I have written A and B in bracket, that means A and B is a list. So L is actually a list. L is actually a list, and the list will contain two values. The first one is A and the second one is B. Okay. For changing these values, I can use the keyword set. Okay, set can be used to change the values. To change the value of x, I am writing set exclamation space x3. Okay, so I am writing set exclamation space x3. So what I am doing, actually x was having the value 2. So if I execute this, what happens? The value of x changes to 3. So you can see that by using set function, you are changing the variable, the value of a variable. That means you are importing side effect to scheme language. So assignment is an option. Okay, it is a feature of scheme which imports side effect to the language. Okay. Likewise, if I am writing set char. Okay, set char of L as C and D. Okay, SL is CD. That means CAR means it will return head, right? So I am setting the head of the list as C, D. Okay, so actually what happens here, the head was A. Now the head is changed to list C, D. Okay, initially the head of the list was A. The first element is called the head of the list, right? So initially the head of the list was A, it was replaced by C, D. It was replaced by C, D. Okay, so the list is C, D, then it is B. Okay, in the next step that we can see that set CDR. CDR, what happens? You know, CDR is used to return all the elements except the head. It will return all the elements, means it will return all the tail elements of a list. Okay, all the elements except the head. So set CDR LE means what happens? Actually, it is replacing. The tail elements by E. It will be replacing the tail element. Here the tail element is B and it is replacing it with E. It is replacing it with E. Okay, so set CDR means it will change the tail element. Set CAR means it will change the head element. So actually the resultant list will be C, D and G. So if I display X, what is the final value of X? The final value of X is 3. Okay, and if I display L, what is the final value of L? The final value of L is CD, which is a head. So that we are putting it in bracket. Then there is another element which is E. I hope it is clear. Okay, so this is one of the thing which involves side effect. One of the features that involves side effect to scheme language. Okay, now begin. Okay, so if I am writing a begin statement, then whatever returned in this, whatever steps returned inside the begin statement executes one by one. Okay, so begin, then first it will display high, then it will display more. So you can see that the statements are executing as a first statement followed by second statement followed by third statement. So whatever I have written in begin, inside begin, if there is what first statement, then second statement, then third statement, it's executed. Which is similar to the procedure language. Okay, so we can say that begin also involves some side effects. Okay, and next one is the iteration. And in iteration, this is an example for, there's other two examples for iteration. First one, it is actually like a do while loop, and the second one, it is for each. Okay, you know that in Python we have learned something of for each. Okay, so you can just go through it. Okay, it's a symbol. It is used to, this is the program to find the first n plus 1 Fibonacci series numbers. First n plus 1 Fibonacci series numbers. Okay, so here you can see that first the value of I, initially the value of I will be 0, and in each notation, in each iteration, the value of I will be incremented to I plus 1. Okay, we are using the British notation, so plus I1. Likewise, we are using a variable A. And the initial value of A is 0, and in each iteration it will be having the value B. Similarly, B is another variable. Initial value of B is 1, and in each iteration we will be adding the value of A and B, and we will be storing it in B. Okay, so after that we will be checking the condition. So this is a condition. Okay, termination test. This is a termination test. I equal to n, and the final value is B. So in each loop, what we will be doing is we will be displaying each loop. We will be displaying B. Okay, in each loop we will be displaying B, and we will be displaying a spaces. Okay, so actually this is for Fibonacci series, and I hope you understood the program. Okay, so iteration is actually, you know that this execute as if it is a procedural language. Okay, this execute as if a procedural language. Okay, so this involves some side effects to the scheme language. Okay, now we can see that this is another one, that is for each lambda AB display star AB. Okay, so here actually A and B are list. So for each elements of A and for each elements of B, we will be multiplying each corresponding elements. So here you can see that, and also we will be giving a new line, right? We will be giving a new line. So what happens? So that AB the first list, that is 246, and if B is the second list, that is 356. So this is the first list and this is the second list. And if you are giving to this function, actually what happens is, first you will be getting an output 2 into 3, that is 6, that is the first one, then a new line, then next one is 4 into 5, that is 20, so that is the second one, and then you will get the third one, 6 into 7, that is 42, then again a new one. Okay, so this is below. Okay, similar to the list operation for X item in list, we used to write in Python program, right? Okay, so this is it. So I hope it is clear. So these are the three things which involves side effect here scheme handling. So don't forget, the first one is assignment, the second one is begin, and the third one is iteration. Thank you.
Hi friends, so we are moving to the next topic, that is strict and non-strict function. So we'll not be dealing in detail with this, we'll just say what a strict function is and non-strict function is. Okay, so what is a strict function? Okay, a strict function is a function in which if any of the arguments is undefined, then the function will be undefined. That means it will either it will not return a value, it will go to an undefinite loop, or it will return another value. I hope it is clear. Okay, a function, if it is any of the argument is undefined, then if it go for a indefinite loop, or if it returns an error, it is called a strict function. And a function which is not strict is called a non-strict function. Okay, clear. So that's all you need to know about strict and non-strict functions. You need to know much in detail. Okay, ML and Scheme are examples for strict function. Miranda and Hazel are examples for non-strict function. Okay, you need not know much in detail about this strict and non-strict function. That's why not explaining much. Okay, so next one is lazy evaluation. In lazy evaluation, what happens is, if there is something to be calculated, for example, if there is something like plus 2 3 need to be calculated, so you know that plus 2 3 is 5. Okay, so what happens is, if plus 2 3 is to be calculated, then it will calculate plus 2 3, that is 5. The value 5 will be stored, 5 will be calculated, and 5 will be stored. Okay, here we are storing it in a list called memo. Here we are storing in list called memo. Okay, and at the same time I am setting the done as true. Okay, so initially the done will be equal to false. Initially done will be equal to false. Okay, so when I need to calculate plus 2 3, but I will calculate plus 2 3. Okay, I will calculate plus 2 3, and I will set done as true. That means I have already calculated. To understand that I have already calculated, I will set done as true, and the resultant I will store it in memo, a list. Okay, so when again in somewhere in the program, if I need to execute the same function, that is plus 2 3, if I need to execute the same thing, then what happens, instead of evaluating this, we will check whether the done is true or not. Since the done is true, that means we have already calculated the same. Okay, and the value is stored in memo. So instead of calculating this, the function will return the value stored in memo. Okay, so we can reduce the evaluation time, or reduce the calculation time. That's what we are doing in lazy evaluation. Okay, so if a function is executed one time, then instead of repeating the function again and again, it will store the result somewhere and it will return the result when the function is called. So this is called lazy evaluation. Okay, for example, we can see here, this is how it is implemented. This is how it is implemented. Okay, so f is a function. Okay, the name and in this function I have initialized the done as false. Okay, here we are initially the value of done is false, so I am storing the done as false. Okay, likewise, okay, likewise, initially the memo where we store the resultant value, it is initialized as empty list. So memo is initialized as an empty list. Clear. Now code lambda plus 3 4. So this is the function. Okay, so this is a thing that we need to be executed plus sorry star 3 4. That is star 3 4. That is 3 to 4. That is 12. Okay, and if the code is like this, if done memo, that is if done that is if done is true, then it will return memo. Okay, if done is true, then it will return memo. If it is not true, then it will go to begin set memo code. Okay, set memo code means code, that is this one, that will be the resultant value, that is star 3 4. The resultant value will be stored in memo, that is will be stored in list. Okay, and here there is one more statement, that is set done hash true. Set done hash true, that is if you calculate it once, you will set done as true and you will return memo. Clear. So you will be if it is already calculated, you will return memo. If it is not already calculated, then you will add the result to the memo, that is a list. Okay, and done is set as true, so that we need not calculate again, and memo is returned. Okay, I hope it is clear. So we'll use this function, that is define double lambda of x plus xx. Okay, so this is a function, and if I am calling the function like this, double of f, if I am calling the function like double of f, if I need to call this function. Okay, so what happens? So double of f means you know it is f. So what is f? So double of f, so f is the argument, so it is same as plus f. Okay, so here x is argument, here f is argument, so plus f. Okay, here we know that f is a function. Okay, so first what we see, first it will check whether done is false. Actually the done initially the done is false. Okay, then what happens? Memo is an empty list. Okay, done. You know the code is something like this. Okay, so first what it will check whether it done is true or not. If it will check whether done is true or not. Initially the done is false. So here if done, it is wrong. Okay, the condition is false. So what happens? Begin. So it will set memo code. That means code is star 3 4. So the resultant of star 3 4, that is 12. The 12 will be stored in the list memo. So the memo list will be having the value 12. Okay, so memo list will be having 12 and done is set as true. Now the value of done is true. The done is set as true. The value of done is true. Then it will return memo. So what is returned? A list of 12 is returned. So it is plus 12. Clear. So here we calculated star 3 4 we calculated. Okay, in the next time again f is required. Okay, again f is required. Here what happens, again it will go for f. Here it will check whether done is true or not. We have already set done as true, right? So here done is true, so you are not again calculating star 3 4. Instead you will just return memo, so that you are not calculating it again. Okay, so what it returns, it will return 12. Clear. So here you got two values. The first value you got because you calculated star 3 4. Second value you haven't calculated star 3 4. We have already stored that resultant value of star 3 4 to the memo list. That's how you got the second 12. Okay, so this is called lazy evaluation. So this is called lazy evaluation. I hope it is clear. Next important topic that you need to deal with is higher order functions. Higher order functions are more complex functions that are used in scheme language. One of the example for higher order function is map. Okay, so in map what happens is there will be an operator and that operation will be executed for the corresponding elements of two list. Okay, if I am using star, the first and this is the first list and this is the second list, then the resultant list will be 2 into 3 will be the first element, that is the first element of the first list multiplied with the first element of the second list. So 6, 2 into 3, 6 will be the first element, 4 into 5, 20 will be the second element, 6 into 7, that is 42 will be the third element. So this is an example for higher order function. Okay, likewise we can define higher order functions. If I am writing fold plus 0 and I am inserting a list, then what happens? It will give out 0 plus, so this is the initial value, so 0 plus 1 plus 2 plus 3 plus 4 plus 5, which is equal to 50. That is, it will sum up all the elements in the list. Likewise, if I am writing fold star 1, 1, 2, 3, 4, 5, the resultant will be 1 into 1 into 2 into 3 into 4 into 5, which will be equal to 120. Clear. So this is how fold function works. So these are two higher order functions. Okay, if you need to understand the logic, you can just remain here. Okay, so how this fold function happens? Okay, so you know that I am giving 0 plus a list, 0 plus a list. Okay, so what I need to take is I need to take one element from, okay, I have to extract one by one element by one element from this list. To extract one element from this list, I will be using CAR. Okay, if I am using a CAR on this list, CAR actually what it does, it will give out the head element, that is the first element. So if I am using CAR of the list, I will be getting 1. Okay, so I will be adding 0 plus CAR of the list, that is 0 plus first element, and I will be recursively calling this using, instead of passing the entire list, I will be passing CDR of the list. Recursively I will be passing CDR of the list, so I will be I will be passing all the elements except the first element, so it will be 2, 3, 4, 5. So 0 plus 1, that is 1 will be 1 and 2, 3, 4, 5 will be passed. Okay. Again, if I am taking CAR of this list, I will get 2. So again 1 plus CAR of the list, that is 1 plus 2. And again I will be passing CDR of this list. So I will be passing 3, 4, 5. Until this is empty, I will just return it. Okay, when it is empty, what happens? All the elements will be added here. And here it is stored in the variable I, and the I will be returned. Okay, that is, if null of list, then I is returned. Okay, so this is how the fold function works. I hope it is clear. Okay, and this is another important topic, that is querying. Okay, querying. In querying, what we will do is we will be replacing a multi-argument function. You will be sorry, this is a multi-argument function. You will be replacing a multi-argument function with a single argument function. Multi-argument function is replaced by single argument function. Okay, here for example, you know how to define a function to add two numbers, right? So I'll be writing like define, okay, plus, and plus I am defining using lambda, and I have two arguments AB have the arguments, and what I do is I'll just add them and it will return it. Okay, so this is a function which do have two arguments, A and B are two arguments, so this is a multi-argument function. Okay, so to change, but in querying, what we will be doing is we'll be replacing this multi-argument function to a single argument function. Okay, the single argument function of this is given here. So here what you do is define query. First I will be giving a function, that is lambda a. Okay, defining a function with a single argument. Okay, inside this function body I will be defining another function with an argument b. Clear? So first I will be defining a function with the argument a. Inside the function body I will be defining the function with argument b, and inside the body we will be doing the same, plus ab. Okay, so actually what you have done, you have changed a function with two arguments. You have changed from a function with the two arguments to two functions with one argument. That's what you are doing in query. Okay, so it need not be two arguments. If it is three, then there will be three functions with one argument. Okay, so and this is how we will be calling the function queried plus. So this is queried plus, this is function, and 3, so 3 will be going for b, and 4. Okay, so 3 and 4. Clear? So the resultant, you will be adding this 3 and 4, and you will get as 7. I hope it is clear. Okay, so this is called query. So you will be replacing multi-argument function with a single argument function. So this is called query, and it is a very important question. Okay, so thank you. Hi friends, so we are moving to the next topic, that is the logical programming, and in logical programming we will be dealing with a language called Prolog. So Prolog is a language that will be Prolog. Sorry, Prolog. Okay, Prolog. We'll be dealing with Prolog. Okay, so I'll be defining. There are some theorems, definitions that you need to know. After definitions, we will be moving to what a Prolog language is, and we'll see what it is. Okay, so just we'll move to the definition. So first of all, you have to know there is something called a font close. Font close is something which do have head and set of values. So if I am writing font 1, okay, font close, and there will be a set of values h1, b1, b2, b3, etc. So that's how a font close will look like. Okay, and there are three things that happens in a close. The first one is a constant, second one is a variable, and third one is structure. Okay, so the first thing is constant. Constant can be an atom or a number. Okay, number means it can be an integer or a floating point number. Atom means a set of characters. It can be set of characters, but it should be in small letter. Set of characters which start with a small letter. Okay. Next one is variable. Variable is the set of characters, but it should begin with an uppercase. Okay, variable is a set of characters which can with uppercase. Okay, and next one is a structure. A structure will be containing an atom called a functor and a list of arguments. Structure. A structure contains an atom called a functor and a list of arguments. Okay, I'll be explaining all this using a example, so no need to worry. Okay, and Prolog do consist of three things. The one is facts, the other one is rules, the other one is queries. You have already learned some logic, programming logic. Okay, logic program. Already you have learned logic programming in a DCS or something. Okay, so facts without a right hand side it is called fact. Rules close with the right hand side is called rules. Queries will start with a question mark. Okay, so all these things we have, I think you understand. If not, you will understand if we look at example. Okay, so this is a logical programming. Okay, so listen here. If I am asking rainy in bracket Seattle. Okay, so Seattle is a place. It is rainy. Again, rainy Rockstar. Okay, and here I am asking question rainy of sea. Okay, so first I will start with constant. Here you know that Seattle. Okay, Seattle is a list, is a set of characters starting with a small letter. So this is a constant. This is a constant, and also this is also a constant. Okay, all the is a set of characters starting with small. So it's just because Seattle and Rockstar can be called as an atom. Okay, and here C, you know that it is a variable. C is a variable because it starts with a capital uppercase letter, so it is a variable. And you know that rainy, it is like rainy and you are writing something in bracket, so this is also a name and there is something called a bracket, so this is called structure. Okay, so Seattle is a constant, Rockstar is a constant, C is a variable, and rainy is actually a structure. Clear? Okay, so I hope you understand what a constant is, what a variable is, and what a structure is. Okay, now we have learned three things. The first one is fact, then rule, then query. Okay, in this there is no rule. There is nothing called a rule. There is nothing called a rule. Okay, we can see that rainy of Seattle is fact because it is true. Fact is said that it's a fact. That means it will be true. Rainy of Rochester is also true. Rainy of Seattle is true. Rainy of Rochester is true. Okay. Then the last one is query. Okay, so these both rainy of Seattle and rainy of Rochester is a fact because it doesn't have any right answer. And there is something with start with a question mark, rainy of sea, that is called a query. Query start with a question mark. Okay, question mark hyphen rainy of sea. So this is a query. Okay, I hope you already know how it execute. Okay, rainy of Seattle, rainy of Rockstar, and if I am asking rainy of C, C is a variable actually. Okay, rainy of C. C is an variable. So what all atoms to which it can correspond to will be returned. Okay, which all constant to which C can correspond. Okay, which makes the range of C true. Okay, if I am writing like this, to make range of C true, to make this query true, range of C true, I am already said that range of Seattle is true, range of Rockstar is true. Okay, range of Seattle is true, range of Rockstar is true. To make, if I am asking query range of C, to make range of C true, to make this thing true, C can have any of the value, right? C can have, if C has having a value Seattle, C is having the value Seattle, range of C is range of Seattle, which is true. Okay, likewise if C is having a value Rockstar, okay, if C is having a value Rockstar, range of C is range of Rockstar, it is also true. So if I write a query like range of C and if I press an enter, I will get C equal to Seattle. So C is C equal to Seattle is a condition in which range of C will be true. And if I press enter, again, you will get another answer C equal to Rockstar. If I press enter, you will get another answer that C equal to Rockstar. Just because even if C equal to Rockstar, then also the value of range is true. Okay, let's consider if there is one more variable, range of instead of rainy I am writing sunny of Delhi. Okay, I have written one more statement, one more fact. The first fact is sunny of Delhi, second one is rainy of Seattle, third one is rainy of Rockstar. Okay, if I am saying rainy of C, C can have how many values? C can have 3 values. But if I take C as Delhi, rainy of Delhi is not defined anywhere. It is not told that rainy of Delhi is true. So C won't be taking that value. Again, the resultant will be C equal to Seattle, C equal to Rockstar. Okay, if I am taking, if I am writing another one, that is if I am writing rainy of Kolkata. If I am writing rainy of Kolkata, and if I am asking rainy of C, then C can have Seattle is an answer which can C can hold. Rockstar is a constant that C can hold. Also, C can hold another constant that is Kolkata. So C equal to Kolkata also will be stored. Will be displayed. Okay. Likewise, this is another Prolog program. Here I have set rainy of Seattle. Okay. Again I have wrote rainy of Rockstar. So I am saying that rainy of Seattle is true. Likewise I am saying that rainy of Rockstar is true. And again I am writing cold of Rockstar. So cold of Rockstar is true. Okay. And this one, this is called the rule. This is called the rule. Okay, that is snow of x. Snow of x is defined by rainy of x and cold of x. If it is rainy of x and comma means and rainy of x and cold of x, then we can say it as snow of x. If it is rainy of x and cold of x, we can say that it is snow of x. Okay, so if I am asking here, the query is question mark snow of C, snowy of C. If I am asking the question mark snowy of C, to make this true, okay, so to make this true, what you have to do for snowy of C? So you should find a variable C. We should find a value for C. To become snowy of C, what happened? It should be rainy and it should be cold. So you have to find a value which is rainy and also which is cold. You know that in Seattle, if I am taking Seattle, Seattle is rainy, but nowhere it is told that it is cold. But if you take the case of Rocky Star is rainy and Rocky Star is cold. Okay, so rainy and cold. So this, if I write a query called snowy of C, C will be having a value Rocky Star because it is rainy and cold. I hope it is clear. And so this one is called a rule. This one is called a rule. It do have right answer. It has right answer, so it is called a rule. This is a function. Seattle, Rocky Star are what they are called the constants, and X and C are called the variables. Snowy of C, question mark, snowy of C is called the query. I hope it is clear. So these are the basic fundamentals of rule. Thank you. Now, in this slide, we'll be dealing with the resolution and the unification. Okay. So, when you deal with this prologue, three things that you need to learn. The first one is resolution. Second one is unification. Then the third one will be learning with backtracking. Okay. So here, okay. So what do you mean by resolution? Resolution says that if C1 and C2 are too close, too home close, and C1 matches with one of the items of the body in the C2, then we can replace the term in C2 with the body of C1. That is, if there are two home close, let it be C1 and C2. Okay, so C1 is a home close and C2 is a home close. Okay, and I say that this is just an example. So this is a head. Okay, so this is a head, and these are the tail of C1. Okay, and the C2 is another on close. So this is the head, and this is the tail. This is the body of the on close. Okay, so C1 and C2 are two on close. Let it be. Okay, this is just an example, just to make you understand. I'm writing this. Okay, so as resolution says that, in resolution it says that you can see that C2 is a home close, and one of the item in the body of C2, matches with the head of C1. Right? One of the item in the body of C2 matches with the head of C1. Okay, so this home close says that the resolution says that you can replace the body item, the item in the body with the body of C1. That is, you can just rewrite this as C2 as A, B, and you can replace this H with Y and Z. So it can be Y, Z. Okay, this is what the solution says. Okay, again I'm saying if C1 is an onco and C2 is an onco, and in C2 one of the item in the body of the oncos matches with the head of C1, then you can replace the item with the body of C1. I hope it is clear. Okay, so that is resolution. Okay, now next one is unification. Unification means if you need to assign values to the variables. Okay, you need to assign values, or you need to give values. Okay, we say it as unification. And unification has two things that you need to be noted. If it is a constant, it unifies only with the C. If it is a constant, it unifies only with the C.
Okay, if it is a variable, it will unify with anything. If it is a variable, it will unify with anything. If it is a constant, it will unify with only itself. Okay, now you know what a resolution is, you know what a unification is. With a resolution and unification, we can just uh, solve a problem. Okay, with using the same thing. Okay, same problem, we can solve it. Okay, so we will explain the resolution and unification. We'll take this example. Okay, so this is a first clause. Okay, this is a first clause, and the first clause found clause, and this is a fact. That means there is no right side. This is the second found clause, and this is also a fact. It doesn't have right side. And this is the third one, fourth one, which is also a fact. And you know that this is a found clause. It do have right side, so it is called a root. So this is a root. You can call this as a root, and all others as fact, because fact doesn't have a right side, but root do have a right side. Okay, now let's consider that for this x as j into O, and let z be okay, let z be CS254. Okay, let h be j into O and z be 254. Okay, so if x is j into O and z is CS254, then you can see that this will turn to be, that is, classmate z x is j into O. Okay, so this is j into O, comma y is takes of x, that is j into O, comma CS254, which is the set. Set value is CS254, comma takes y, comma z is CS254. Okay, so that is CS254, y and CS2, because z is CS254. So here also y is z is CS254. Okay, so this is how it happens when x is j into O and z is CS254. You know that in resolution you have already solved. You can take this as C1 and this as C2. You can see that this is the head of C1. This is the head of C1. Since it is a fact, it doesn't have a body. Okay, this is a fact. So C1 doesn't have a body. C2, you know that this is the head of C2 and this is the body of C1. I'm sorry, C2. That is the body of C2. Okay, so when you take off resolution, you can see that when the head of C1 matches with the item, one of the item of body of C2, then you can just replace the body of C1. Here the body of C1 is null. Here the body of C1 is null. So you can just replace body of C1 with null. Okay, that is null with the item. So you can just replace this takes with the null. So the C2 will change to classmate j into comma y. Okay, you have replaced this term with null. See the body of C1, which is null. Okay, and it will be equal to takes of y comma CS 254. So that is called, and this is called what? Resolution. Okay, so we have applied the rule and you have resolved this classmate j into comma y into a smaller one. Okay, now next is unification. The specialty of unification is that you have two terms here. The one is a constant term which is CS254,
CS254 is a constant term, and capital Y is a variable. Okay, the advantage is that for unification, what you can do is you can just you know that in unification variable can take any value, but constant cannot be changed. Okay, but constant cannot be changed. So you can just try to unify using any of the any of the facts, okay, which has takes of Y comma CS254. We have already taken this, so you cannot um, okay, you can not you can just check, we can move to the next one. Okay, takes of Y comma CS254. You can see that CS254 is there. Here also CS254 is there. Okay, which cannot be changed. So the second argument of takes cannot be changed. So it is CS254 which cannot be changed. Y can take any value, right? So here, since CS254 cannot be changed, you cannot use this one because the second argument is ART302, and you cannot take this one because the second argument is HIS201, but you can take this because this and this because it is CS254. The second argument is CS254. And if I take this takes of Y, so Y can take any change value. Okay, so Y can take the value of Ajit Chandra. That means this can be unified. Y is unified with the value Ajit Chandra. So this is same as taken of Ajit Chandra, comma CS254. Clear? That is called unification. You just match with the value. Okay, the two rules are the constant cannot take change the value, but the variable can take any value. So this is same as CS Ajit 254. So the Y is taking the value Ajit Chandra. So here you can see that it will be changed to classmate Jane Doe, comma Ajit Chandra, and there is taken Ajit Chandra CS254. If you resolve this, Ajit Chandra CS254, it doesn't have a body, so that is none. So this can be replaced. There is no term like this. Okay, so that is two terms. The first one is resolution, the second one is unification. I hope it is clear. Okay, now we'll move to the last topic, that is backtracking. Okay, so what is backtracking? Backtracking means we'll start from the goal. Okay, you will start from the goal and you will just resolve by going to the pre-existing clauses. You will start from the goal and you will move to the try to reach the pre-existing clauses. That is called backtracking. Okay, so let's see here. So you all know that this example. The first one is Rainy of Seattle. Second one is Rainy of Rochester, Cold of Rochester, Snowy of X, Rainy of X, comma Cold of X. And the question is Snowy of C. The query is Snowy of C. Okay, the query is Snowy of C. Okay, so backtracking, how the prologue finds out the correct answer for this. That is the question. Okay, so you know, if I am writing Snowy of C, okay, I have written Snowy of C. So if I am asking Snowy of C, and if my query is Snowy of C, it will check for the rules and the facts, and it will see there is only one rule which says about Snowy. It says about X. Okay, so this Snowy of C is changed as Snowy of X because in query it is Snowy of X. Clear? What do Snowy of X means? Snowy of X means it should be rainy of X and also it should be cold of X. So it has two parts. So Snowy of X do have two parts. The first one is rainy of X. The second one is cold of X. Rainy of X and cold of X. Now we'll start to unify and we'll try to find out which all values satisfies both the conditions. Okay, so first it will to check the snowy of x, it will move to rainy of x. It will take to move to rainy of x. For that, it will initially take the first value that is C at 2. For x, it will take the first value that is C at 2. So you will be checking whether rainy of C at 2. So rainy of Seattle. So it will check for the rainy of Seattle. Yeah, there is something called the rainy of Seattle. So it is true. Okay, so it is rainy of Seattle is true. Since rainy of Seattle is true, what happens? It will go and check for cold of X, where X is a Seattle. So it will check whether cold of X. So if it checks in the facts, there is nothing called cold of Seattle. There is nothing called cold of Seattle. So what happens? It will go back to the rainy of X. It will try to take another combination. Since there is rainy of Seattle but no cold of Seattle, it will move back to rainy of X, so that it will take another value for X. So the next value for X is Rochester. Next value of X is Rochester. Okay, next value of X is Rochester. Now it will check for rainy of Rochester. So rainy of Rochester is true. Rainy of Rochester is true. So what happens? It will again move to cold of X. It will check whether there is cold of X where X is a Rochester. It will check the facts. Now there is a fact called cold of Rochester. So it happens. It's true. So you can see that for snowy of X, both rainy of X is true and cold of X is true for the value of X as Rochester. For X as Rochester, both rainy of Rochester is true and cold of Rochester is true. So what happens? It returns to snowy of X and it will replace X with Rochester. Clear? Then again it will move up. The query is actually snowy of C. Here you know that C is the same as X. So what happens? C will be replaced with Rochester. C will be replaced with Rochester. So snowy of Rochester is true. That means the compiler returns a value, and it will return a value which is the resultant of this query, and the resultant value will be Rochester. That is how actually the problem is solved in Prolog. And this process in which we'll start with the query or start with the solution, then we'll backtrack to the facts, is called backtracking. I hope it is clear. So this is backtracking.